Hello gang, I was asked to make more Sony video or share some more Sony videos, and I'm about to restore this Sony TA-5550 figure. I'm going to share some footage. So this unit, this isn't mine. I have a few of these myself, but this isn't mine. This thing looks like somebody may have called this unit recapped or whatever, service or restore. So looks like there's some new caps. It looks like some of the dead diodes were replaced with two series 4141 or something similar, but everything else was left the same. So this thing fails. It can't hold bias in the right hand channel, and it goes into protection after just a little bit, maybe 30 seconds or so. So it needs a full overhaul. I haven't pulled the V-FETs out to check them. I'm assuming they're going to be good, but again, something to find out. This unit will get a new IEC connector, new speaker posts, likely new RCAs, we'll see. But bottom line, needs full overhaul. The original caps are still here, so this will likely need to be replaced. There's no light in the switch. I'm not turning this thing back on after I observe its behavior. So yeah, I'll keep you guys posted with updates as I progress. Talk soon. All right, here she is, fully taken apart. Everything comes out of the chassis, so I could clean it really well. All the boards are out. I'm gonna have to see if all the service bulletins are implemented. There's a bunch of transistors and resistors that are gonna have to be changing here. A bunch of, pretty much everything else has to be checked. The V-FETs are still on. I didn't take them up, but you could see how much gunk they put on them. So yeah, this have to be pulled out, clean. Actually, first tested and clean. Yeah, here's all the guts. I'm gonna have to service the selectors, and I mean service by, when I mean service, I mean taking it apart fully. Same thing with the spots. It doesn't mean just shooting some dioxide in there, right? A lot of people are saying service this, service that. I mean they don't take them apart. They just kind of squirt some stuff in there, hope it gets better, turn it a few times, and it's gonna work for a little bit, but not for long. Same thing with this power switch. I'm going to make sure that there's very little contact resistance once I'm done cleaning it. Yeah, the speaker posts are going to get replaced. Yeah, everything has to come out because I need to cut in a IEC connector, hole in here for the receptacle. And I'm going to install the speaker post. It's much easier to work this way. This plate, it's actually in very good condition. I'm going to clean it, buff it up a little bit. Same thing with the front plate, very clean unit. It's just gonna some smudges. I'll clean it up. The top cover is very nice, but the size, this is very typical. This is damaged. I'm gonna try to fix it, see if I could fix it a little bit, but I don't want to turn this into a carpentry project, so I'm gonna do what I can, to get this looking better than that, but it's not gonna look perfect. So anyhow, yeah, same thing on this side. There's some here and there, has a few things, but other than that, very clean unit overall. Hoping no surprises from those V-FETs, but I don't think that I will. So anyhow, as I make more progress, I will keep you guys posted. Be right back. Hello friends, welcome back to the shop. Quick update on the progress I made with the restoration of this Sony TA-5550. All the boards are complete and essentially tested at this point. Basically, all the components I wanted to change in these boards, are replaced. Boards are cleaned, and the unit is adjusted and is ready to receive its V-FETs. Let's talk about that for a minute. The adjustments I meant, I tested the DC offset and I set it as close to 0 as possible. I also set the gate voltage at 24 volts. What is interesting to note is that in the 5550, The gate voltage swing, it's quite wide. It varies in this unit anywhere from like 12 volts all the way to above 27 volts. That's quite a wide range. This was not the case in the design of the 8550, the older product. There Sony limited the gate voltage swing based on the V-FET rank for that particular unit. So you would have to actually, if you want to introduce a different V-FET rank in a 8550, 8650 for that matter as well. But in 8550, you would have had to change those resistors. So you would allow the bias swing, the voltage swing to be within the range of the specific rank. So that's important. So I set this to 24 volts. This is a rank 7 V-FET. So we'll talk about that in a minute. All right. So that's set. It's ready to receive the V-FETs. One other thing that I did is replace the power supply board for a couple of reasons. I mean, realistically, the old one is fine. You know, I used Nishikon KG, and these are solder tap types. And they could have been used in the old ones. But I made a different board with multiple capacitor type connections. One of the reasons that why I made the board is I have a pet peeve because the center ground in the old board was actually connected to one of the capacitors. So it wasn't truly in the center. So I want to take care of that. Also the diodes, and we'll see this in a second, the rectifier diodes are kind of spread, so I wanted to get them closer to each other. Also in this case, I use soft recovery for a lower noise floor or lower noise diodes. I also had to change the value of this drop resistor, voltage drop resistor here, which services this switch light bulb, which unfortunately for us, Sony used. See the blue one over there? That's a 4.5 volt light bulb. I had to replace it with something with a little higher voltage. I also had to change the drop voltage to accommodate for that. So I'm also not powering that new bulb at its full potential. So, you know, that way the consumption is the same. This thing works really nice. The light is just as the original. I put an original unit right next to this, so it's the same color and intensity. I could have used an LED. I'm not a big fan of LEDs. If I don't have to use them, I won't use them. So I used a light bulb instead. All right, so that's that. We'll talk about this capacitor fitment in a minute. Let's look at the speaker post. So I changed the speaker post. Obviously, this was a no-brainer going through a detailed restoration like this. You know, it's almost mandatory to change those old, impossible to use speaker posts. Let's look at the back of this amp. All right, so as I mentioned, the back cover was very nice already, so I just cleaned it up. You still see smokes in there from my fingers. I'll clean up really nicely, but as I polish it, looks really nice. So here's the speaker post. Because Sony cutout in the back plate is kind of narrow, we're limited to using the mini speaker post, but these are really nice. They're fine. They work way better than the original ones. We're looking at the new IEC receptacle. It's a two-pronged receptacle. Sony and other 1970s amps don't use a chassis, mains ground to chassis. So we kind of kept that as a grandfathering feature. And then we have new RCAs. I don't normally change the RCAs in the Sonys, like this guy's right here, but I did change them in this unit. On a 5650, for example, where you have all the preamp section, or the 8650, I probably wouldn't change them. But in these right here, it was a no-brainer, easy to do. So easy peasy. Okay, so yeah, this is what else? The speaker selector fully taken apart, clean, put back together. Same thing with this selector switches right here. Same thing with the pots. That's what I meant earlier. Is servicing pots and switches means fully taking them apart, cleaning them, relubing them, putting back together, make sure they work correctly. So that's the story here. Let's set this thing aside and go into a little bit of a deeper detail on the power supply changes. All right, so yes, as I mentioned to you, I wanted to make sure that I could do a center tap on this, so that's how it looks on the back. And as I also mentioned, that this could be used this way, you know, with just essentially just solder this if you're in a pinch. But I wanted to change this to a multi-connector type that would allow the solar tabs. Also, you could see here, I'm using the original capacitors for demonstrational purposes with a screw right in the center, right? And this could be used for other capacitors because this Nishikon KGs that I use in this unit, same as this ones right here, they're no longer made. So this will essentially be out of production. But there are Chemet capacitors that would fit in here, but those use screws. So this would fit, you know, other screw type capacitors. Yeah, here's the selector. Obviously, these are much crappier, and here's how the plate looks for supporting those speaker posts. All right, what else? Okay, let's talk about V-FET. So, as I mentioned to you, someone worked in this amp before, and judging by the lack of attention to detail, to put it nicely, on how the goo was squirted on this heatsink, I decided to test all these V-FETs. I usually test all V-FETs, but I wanted to test them to a greater detail, greater level. So, first of all, these are rank 7 V-FETs, and the 5 in the front of the 7 tells us they are from the first generation V-FETs. This would be original to this unit. This is one of the first generation amps. Second generation Sony V-FETs would be the TA-F7 and the TA-N7, and those would have something else as a front digit. It would not be a 5. It would be a, I think, a 3 or a 4. I can't remember exactly right now, but I think it's a 3. So there you have it. The rank is the 7. And I mentioned to you that I left the gate voltage on that driver board at 24 volts, which means that when I turn the amp on, 24 volts at the gate would really turn off all these V-FETs completely, right? What do we have on this sheet of paper right now? The operating conditions of the Sony TA-5550 and the same conditions for my V-FET tests are 54 volts VDS, so voltage between the drain and source, it's 54 volts. P channel will have a positive gate voltage and N channel will have a negative gate voltage. So forget about the signs in front of the voltage, right? There's no signs in front of the voltage there. Just ignore that. It's what the voltage is what's important. So what does this mean right here? We're searching for VGS. We're searching for voltage at the gate, which would allow the transistor to turn on just enough to allow 150 milliamps to be conducted between drain and source. So the exercise is at what VGS does the transistor conduct 150 milliamps IDS? So I mark this with small numbers because they are nearly, I mean, they're identical. They are original. So they're all HA57. And so what I wanted to see is if they were first A, if they're original, and they are, because I tested them at operating conditions and they work great. They have no leakage. There's no leakage there. So they're also I tested them to make sure that they have no leakage at operating conditions. And also I have tested them to make sure they haven't been mixed, right? As I mentioned to you, this unit was serviced before, and judging by the lack of detail with the glue, I was afraid that some of this would have been mixed, and if they would have been mixed where a pair wouldn't be like the octet pair, the pair of the 8s here, or 8 total V-FETs would have been way out of whack. I don't want to have a surprise, but I don't. So like you could see, for example, like this is a little bit of an outlier on the left channel. It's just a little shy of 2 volts comparing to the lowest VGS transistor here, but they're from opposite rank. That's not a problem. Really, the Sony ranks are wider than 2 volts. They're probably like wider than 3 volts. I have to look up my data sheets. Same thing here. We could see like this one, it's nearly 2 volts away from this one. All right, so I'm gonna leave them in the order I pull them out. I'm gonna put them back. I'm just gonna clean that heatsink properly and put enough glue in there, but not so much that it spills all over. So these things are ready essentially to go back in. I'll be back shortly As soon as that's complete, that job is completed, and as soon as this unit is actually working and being under test, I will provide you with more updates. Talk to you soon. Bye. All right, back with more updates on the Sony TA-5550 restoration. So since last time we talked, the unit is essentially assembled, reassembled, put back together. The V-FETs are back in, chimneys are back in. I did find a couple of questionable connectors. I don't like these connectors. I replaced them. I don't like soldering to those pins either, so I want a solder wire to board directly. You could see that white wire right there. Again, I don't like these connectors at all. If I find anything that's questionable, I will replace them on the spot. What else? I did replace this relay, the speaker relay. The original, the one that was in the unit already was fairly new, was not original, was replaced recently. This unit, again, was serviced recently, but my paranoia kicked in, so I replaced it anyways. Also, this unit had, I didn't mention this, but this unit had a problem. This unit was actually broken. That's why it wasn't holding bias. It was not because of the parts that need to replace. It was actually, I mean, it was because of some of the parts that were need to replace, but not your typical transistors and diodes. This unit had a problem, the power supply, that was kind of very difficult to spot. It was a mechanical failure on a resistor that looked perfectly fine from outside, not burned or anything. And that's what was causing this thing actually to go into clipping at very little load and lose bias. So if you remember the beginning of when I started this video, I mentioned to you that this thing couldn't hold bias. It wasn't able to drive almost any load. So anyways, that issue is fixed. The unit is fully restored right now, rock solid. The DC offset is solid around 0 millivolts, maybe 1 millivolt swing or so. I did set the bias adjustment. You could see the original manuals call for 65 millivolts. There is a service bulletin that says set this to 45 to 50 millivolts. This unit, for this unit right now, the bias is set at 50 millivolts. But this unit is pushing 1 watt into an 8 ohm load. So you could see my reading on the right hand side right here for this meter. This monitor is the right side bias, and this one the left. It's a little higher than 50 because this unit is under load. So what else? Yes, we have, like I said, I have an analyzer hooked up to this. This is a typical harmonic profile for a V-FET where your second and third harmonics are dominant. But look, the range is very low, non-audible. So this is very, very low distortion. No issues there. Sine waves, we're going to look at this in a minute. Like right now, this you see this, my scale of my sine waves is kind of low. I'm going to raise it a little bit. Let's do that. And you can see if I move them on top of each other, both channels work really nicely. They already, one disappears because they're perfectly even. Another thing I wanted to mention is, and we're going to go into that next, I did make a couple of short videos. And in one of them, if you look at shorts on my channel, in one of them I featured this unit. And this is the unit, the video is about cleaning potentiometers. And I use an older Sony that I have in here. I mean, the same age Sony that is not restored. Same model, TA-5550, old unrestored unit that doesn't have clean pots. And you could see a major problem with noise generated, basically DC overimposed on the AC signal line on oscilloscope. And then I have this unit, which uses the same 50-year-old potentiometers that have been thoroughly cleaned. Again, I can't overemphasize enough the importance of cleaning the switches, the pots in this. And when I mean cleaning, I don't mean squishing some deoxide in there. This needs to be fully taken apart, cleaned with alcohol, re-lubed, put back together, so then you could get this type of result. So let's look right now at while I operate the spots, the gain will change, but you could see there's no more of that DC noise happening across the AC signal line. Go and watch those short videos, you'll see what I mean. With the dirty pots, you have noise that almost turns into a straight AC line across the AC, and that goes straight into your speakers and can really not just ruin your eardrums if you're doing it at a high gain, but it could ruin your tweeters as well. So anyways, very critical that you clean those spots properly and not just you know, do a half-assed job if you're ever servicing one of these units. All right, the next thing I wanted to do is to look at what power does this amplifier starts to clip at. So let's change my scale a little bit to make sure I have enough, because you'll see in a minute that this amp is actually seriously underrated by the factory. It's conservatively rated at 50 watts, but it's actually a much more powerful amp than that. So let's, if we're monitoring, let's look at the, all right, let's see if I get in focus. Okay, you could see there I have my channel 1 and channel 2, and that is volts RMS. This is again into pushing an 8 ohm load. Let's see at what voltage does that start to clip. So you see almost 27 plus, almost 28 volts. Let's do the other channel. Let's leave it right below clipping. Let's do this one. Same, you see 27 to 28 volts. That's when they're starting to clip. That makes this amplifier actually a nearly 100 watt amplifier, definitely over 90 watt amplifier. Same with the 5650. These amps are really conservatively rated by Sony. They're really punching way more power than rated, and they're also given a lot less credit than they should get comparing to their bigger brothers. Anyhow, oh, you could see how nicely this the bias settled on the multimeters here to just about 50 millivolts. All right, yeah, really nice. I'm very pleased with this restoration. I like the modes for the amp. They're really nice. Amp cleaned up really well. The next thing that I need to do is I still have to fix that wood side panel. I don't like carpentry projects. I'm not going to share that with you. I mean, that's boring. But I think the restoration video is getting kind of long. So I still want to share with you my listening impressions of this amp. So I think we're going to end this video here, and we're going to see each other again with a new video about this amp playing in my listening room, and there I may share some of my thoughts on the sound signature of the amp. So if you have any questions or any observations, or you want to make any comments, any suggestions, please let me know in the comment section. And if nothing else, then we'll see each other again in the next follow-up video where we're going to be listening to this amp. Talk to you soon. Bye-bye.